right, hello guys. Let's move you over a little bit. So my apologies, during class, this video did not record for some reason. So we're gonna have to go through it separately without the class now. So we are moving on to the portion of 4.5 that's dealing with a C value. Okay, so keep in mind we've dealt with A values, B values, negative A values, and now a C value. So when dealing with a C value, the way that would look in an actual function would be A sine quantity bx minus C, or A cosine quantity bx minus C. So the C value is going to come inside the parentheses, and the parentheses are important here. Right, the parentheses mean something huge to this. If they're not in parentheses, then it's not truly a C value. That would actually be a D value, which we'll get onto in a little bit. So in the next section, I should say. So what a C value does is it shifts us horizontally. So we're going to create a horizontal shift because of this. This horizontal shift is going to happen based on what that C value is. So we're either going to shift left or right. This will probably be opposite because you're looking at me the other way. But essentially, if we're shifting left and right, we're going to have new left and right endpoints, or starting points, right? So usually for a sine or cosine function, we start at 0, 0, and we go to 2 pi. Now we're going to be either going this way or this way, so our starting point and our ending point of our first period are going to be different. So in order to find this new left endpoint, right, or essentially starting point of our first initial period, we're going to have to use the function or the formula bx minus c equals 0. And we will solve for x. Okay, and to find our right endpoint, we will use the same thing, bx minus c, but it equals 2 pi. And again, solve for x. So why are we using, oh, you couldn't see that part. So why are we using 0 and 2 pi? So 0 is where our normal starting point is, and 2 pi is also our normal ending point. So we want to say, well, what is this shift doing to us? Is it moving us left? Is it moving us right? Where is the starting point now? And now where is the ending point? Okay, so we're going to get right into an example here. Recording. So in this example, we have to graph, let's try y equals 2 sine x minus pi over 2. Oh, you can't see that either. Y equals 2 sine quantity x minus pi over 2. So the first couple things we're going to want to do here is identify our A, B, and C. Now that we have a C, right, we go all the way through all the ones we've already talked about. A, B, and C. Our A value is always that first term, right? It goes y equals A sine bx minus c. So our A value is what's out in front, which here is going to be 2, which essentially just means we are going to go up to 2, down to negative 2. So then when we're talking about our B value, it is bx minus c. So b is out in front of this x. There's essentially no number out in front of that x, so let's assume to be 1. It'd be 1 times x, which is just x, so b is 1. Which is good for us in this circumstance, because if we don't have a b value, we don't actually have to find a new period length, right? Our b is going to stay the same, which means our period length will stay the same. Our c value here is whatever's subtracted off. So it's pi over 2. So a lot of people will go ahead and say, well, this is a negative pi over 2. It's minus pi over 2. But look at the original function of this formula. There's already a built-in negative. So if I claimed that pi over 2 is negative, what I'm claiming is that this is x minus negative pi over 2, right? Which would be x plus pi over 2. So, or x minus, I think, I don't know if I said plus or minus that first time, but it'd be x minus negative pi over 2, which would be x plus pi over 2. So this actually is a positive pi over 2. You kind of want to take the opposite version here. So what this means for us is we want to go ahead and find our left endpoint, which is x minus pi over 2 equals 0, and our right endpoint, x minus pi over 2 equals 2 pi. With this one, we're just adding that pi over 2 right over to get x equals positive pi over 2. Again, this is our starting point. So let's label this on our graph, pi over 2. That's going to be our starting point. Now we want to find where we're going to end up at. So we have to solve this by adding that over. So now we have 2 pi plus pi over 2. So we need to make a common denominator here to be able to add 2 pi to pi over 2. My current denominator is 1. So I need to multiply, or I didn't need to make this a common denominator of 2 because this one's already 2. 1 times 2 gives me 2. So I have to multiply my numerator by that 2 as well, giving me 4 pi over 2 plus pi over 2. So my right endpoint is 5 pi over 2, right? 4 pi over 2 plus pi over 2, 5 pi over 2. So now let's go label that on our graph. That's way out over here, 5 pi over 2. So again, let's keep in mind, a normal sine function or cosine function starts right here at the origin. I've now shifted that from here over to here. Let me lift my hands up. We shifted here to here, here to here. So what this would be my 0, 0 originally. So I need to make 4 sections between this point and here. So I have 1, 2, 3, 4. Okay, so 4 total sections. 1, 2, 3, 4. Essentially it adds up to 5 kind of tick marks here. So we need to kind of just be able to figure out what are these numbers. This is awesome and this is awesome, but I need to know my numbers in between. Sometimes this is going to mean that you have to kind of break this apart and figure out, well, what would 4 equal sections between those 2 points look like? In this case, we can just test something. If I'm going from pi over 2 to 5 pi over 2, there's 4 numbers in between there. Or not 4 numbers, but essentially, are those going to be my 4 equal sections? So if you counted this up for 1, 2, 3, 4, 5, it would go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, of course, 2 pi over 2 simplifies down to pi. 4 pi over 2 simplifies down to 2 pi. Again, those are kind of minuscule details here that I'm not as concerned about, but making sure that these are actual accurate measurements. You will not be able to do just this counting straight up every single time. Sometimes you might even have to completely change the denominators and kind of divide these up a little bit differently. In this case, it worked out really good. We can go ahead and actually graph this. Sine functions start down. So we start down here on the axis. This is also a positive sine function. So I am not flipping, right? So my first point goes up, down, all the way down and back up. One thing I want to make sure of is that you don't just draw this. While this is awesome, we want the whole graph. Like if you were to draw a line, you wouldn't just connect 2 points and say I'm done. If you're drawing a parabola, you're not going to say, well, this point, and this point, and then it's it. You draw a whole graph straight through it and keep going on like you guesstimate what's going to happen next. I don't need you to put other points on here, but I do need you to still say, well, I'm going to take this kind of curve, right? And I know I'm still going to keep curving this way, just to acknowledge the fact that this is a continuous function. Okay. This covers all the things that you're going to see with a C value. Always just keeping in mind that I could have a different B value than 1. This formula is going to account for your new left and right endpoint. So if your period does change and there's a C value, you don't really have to essentially find and calculate your new period because your left and right endpoint will do that kind of for you. If there's no C, you do still have to go through that process of finding your new period and figuring out where that stop and start point is going to be. Okay, so this is for C value.